Hey guys, lesson 3.6 here, projectile problems 2. We're basically talking about a projectile fired at an angle and then answering some specific questions, more using the equations than necessarily drawing out every second like we did before. All right, so let's start by drawing out the initial scenario, 35 meters per second at 60 degrees. Remember that looks like this. And draw your components, horizontal and vertical. My VXO is going to, in this case, winds up being 17.5. You could do a cosine there. And then my VYO, I got to figure out quick. It's a 30, 60, 90. I made it easy on myself as far as figuring those out. But normally you would use sine, cosine. Oh gosh. Struggling here. Okay, 30.3 is my VYO. Okay, that's the initial scenario. Our equations, let's write those out quick. Remember V for VY, it was my VYO plus AT, because that's changing every second. The VX is constant. Remember for the displacement, the DY was this big equation. 1/2 AT squared. And then my dx was easy because that's just my VXO times t. Okay, here's accelerating, right? Here it's just at a constant speed. That's the difference. All right, time to the peak. Okay, so the time to get up to here. The key there is, if I look at my equations, it's going to be when my VY is 0. When you get up to this peak here, your VY is 0. So if I look at that equation, I want to say, okay, this is going to be 0 meters per second at that point. My VYO is a 30.3 plus negative 9.8. All right, getting a little squished here, times t, right? So basically just solve this out for t. So minus the 30.3 over and then divide by 9.8. So basically 30.3 divided by 9.8 is all you really need to do. It's 3.09 seconds to the peak. Okay, what is that peak height? Well, now we're talking displacement. dy, my dyo is just 0. My vyo is the 30.3. Again, I'm going to run out of room here. Times t, 3.09 seconds. That's the time to get to the top. Plus, I'm doing here, 1/2, negative 9.8. times the 3.09 squared seconds squared. Okay, so that whole big mess, I'm just going to plug that all in my calculator at once. 30.3 times 3.09, get that answer. Minus, this is 4.9 times 3.09 squared. Okay, I'm getting 46.8 meters. That's the peak height. Okay, the height at that point at 3.09 seconds. Okay, time to the ground actually is easier because the ground, I just take that peak 3.09 seconds and double it. So what, 6.18 seconds, right? Because the time it takes to get to here is going to just double to get back down to here. Okay, it's symmetrical to get up and down. The distance, the dx, which is a total horizontal range, like how far did this thing land from where it started horizontally? VXO times t, right? That's pretty easy. 17.5 times this time, right? Because it's in the air for 6.18 seconds. So basically it's just traveling horizontally, constant speed, 17.5 meters per second for 6 seconds. 108.2 meters. That's how far it would travel horizontally. This is all ignoring air resistance, obviously. But if there's no air resistance, that's how far that projectile would go. All right.